Now, in reality, if we hit the ball with a certain velocity, here we have the speed 50 meters per second and certain angle alpha, the ball will also move in the parabolic path. Therefore, to solve this problem, it's important for us to separate the initial velocity in the x and y direction. This is the initial velocity in x direction. We call that Vox, and also the initial velocity in y direction, or Voy. And now it's a mathematical calculation to find the value of Vox and Voy. And we can use a right angle triangle here. If this is alpha and this is V0, this is Vox and Voy. Therefore, the value of Vox will be V0 times cosine alpha, and the value of Voy here will be V0 times sine alpha. But you don't have to memorize this, since that depends on the location of alpha here. Now, if I give you an example, suppose the value of sine alpha is 0.6, and of course by using simple trigonometry you can find also the value of cosine alpha, and it will be 0.8. Therefore, you can find the value of V0x here. It will be 50 times 0.8, and you get 40 meters per second. And also you can find the initial velocity in y direction V0y, and it will be 50 times 0.6. You get 30 meters per second. Now, it's important for you to remember that in x direction or horizontal direction, the value of V0x will be constant, since this is motion with constant velocity. Constant. So therefore, once you get the value of the initial velocity in x direction, it's 40 meters per second in this case, and the initial velocity in y direction, it's 30 meters per second, then you can just go using the same process. Therefore, you can find that the time needed to travel to this highest position will be 3 seconds, and also the highest distance here will be 30 times 3 divided by 2, and the horizontal distance here, since that's due to the motion with constant velocity and the velocity here is 40, the distance will be 120 meters. And then here the time needed to the maximum point is 6 seconds. Therefore, the distance to the maximum point here will be 240 meters. Now let me give you another example. Suppose we have a ball and the initial velocity of the ball, let's say it's 200 meter per second, and this is the angle here from horizontal axis, it's theta, and you are given the value of cosine theta, let's say it's 0.8. Now we will find the highest point here and then the maximum point of the ball. Alright, first, by using simple trigonometry, you can find that sine theta will be 0.6. Now, let's find the value of the initial velocity in x direction, Vox, and that's 200 times cosine theta 0.8, and here we get 160 meter per second. Secondly, we need to find the initial velocity in the y direction, and that's 200 times sine theta, it's 0.6. You get 120 meter per second. Alright, if the ball moves initially with initial velocity in y direction 120 meter per second, and the ball gets the gravity pull here, g, let's say 10 meter per second square, then it will be at the highest point after here 120 divided by 10, that's the gravity, so you get 12 seconds. Now the highest point we have, it's called y max, and that will be 120 times 12 divided by 2, so you get 720 meters. Now for the horizontal distance here, since the horizontal distance is for the constant velocity motion and the traveling time is 12 seconds, then the distance here will be 160 times 12. Now we can find for the maximum position here, the time needed for the maximum point here will be 24 seconds. Therefore, the distance to the maximum position here will be twice than this distance, and it will be 3,840 meters. In my experience, this is one of the simple problems we have in the projectile motion. Of course, there are still many problems at the higher level, and you can solve the problems using like position coordinate or many other techniques, but at the moment I will limit myself at this point, and we can go to the more sophisticated technique later. In the next video, we will get some practice related to the problems of the projectile motions.